This term we present 5 diverse and interesting researchers who share their work with us over the coming weeks. And as I mentioned in the introduction to the first talk, the concept of women in cognitive science in this case is an opportunity to celebrate and to illustrate for students considering cognitive science the breadth of possibility in this area. Hopefully they'll be inspired across the set of talks that we have here. So today you're here for user experience in video games. Before I hand the mic over to Steve, the Director of Cognitive Science, I just wanted to remind you of the next talk that takes place October 26th. That'll be next Wednesday. And so we invite you to join us for an SFU psychologist, Kathleen Slaney. Her talk is the concept a useful concept? And by all means, do pick up a poster at the end of today's talk. They're just up here on the front, and put them up in your area, on your office doors. It helps spread the word around campus. Also, just before I hand the mic over, I do want to mention that as the advisor, if you're interested as a student in cognitive science and you want to pursue a major or minor and honors in cog sci, just contact us. We'd be happy to offer you some planning and advising, and you can get to us through our website, and just email us through that. And the website, of course, is sfu.ca/cognitive-science. So Steve DePaula is an associate professor. Steve is an associate professor in the School for Interactive Arts and Technology. He's the graduate program chair for CIAT, and he's the current director of the Cognitive Science program.
Hi. Well, this is a great series. I'm so excited by it. There's a number of very strong women, and we have people who are going to introduce each one of them. It's my honor that I get to introduce Veronica for a number of reasons. I think we really want to show that there really are there's quite success stories in cognitive science, and very significant success stories with women in cognitive science, and you'll see that throughout the series. Which is so exciting about Veronica is she goes in between the academic and the industrial sides of things. So she's really showing that within CogSci, there's right now huge interest in industry, and in this case, with her position at Electronic Arts and what she's going to talk about. That didn't come by a fluke or by luck or by answering the right ad. She actually almost created this very position. So she's not only a great person to be talking about what CogSci is doing within the gaming industry, she's also one of ours. So she actually graduated at the School of Interactive Art and Technology, SFU, with a Master's of Science. And she's been putting together psychology and cognitive science with gaming for a long time. So I'll mention that her quite strong master's thesis was in gaming personality and their gaming preference. So she looked at what gamers' personality, and their gamers' preference. So she looked at the connection between a typical personality study people take and then what games they play. Amazing that it hasn't been done. Now, I remember the day she showed up, she knew that is exactly what she was going to do, just because it's a strange situation sometimes, and faculty have money for different things, and she's so smart. I kept trying to tell her, why don't you do this other thing, and then you can do this and that, and she did all those other things. And this, I could never drive her onto some of the other work. So I said that this what she's going to specifically talk about here wasn't just a fluke. While doing a master's and all these other things, she also did a MyTax, and that MyTax is with CIAT faculty Maggie El Nasser, and they specifically looked at this area they're going to talk about now. So MyTax is an industrial academic partnership, so she was at EA, and the results of that MyTax, besides the academic papers and everything else, should be at least a little bit obvious from this very talk, because they wanted to know if this particular area that she's going to talk about is worthwhile from one MyTax and the data that she came up with. They decided it was worthwhile enough to start a new division to do it and hired her to be the person to do it. So I love that part about the local SFU COGS side person actually kind of building and showing the world what's possible. And now she's actively at electronic arts within the user experience research group, which we'll be talking about. But she's also, just because she's got to do so many things at once, is also pursuing her PhD at SFU. So without further ado, I'd like to introduce Veronica Zammitto.
Thank you.
Okay. Thank you very much. And as he explained, I'm going to give an overview of two different projects that was worked on at Electronic Arts, which is right down the mountain. So the campus here is in Burnaby, and this studio is in charge of the EA Sports label. So a bunch of FIFA, NHL, Madden, all those games. So I'm going to show you this game user research study. It was a combination of different methods and how to put them together and get results that will be applicable for game design. So as Steve mentioned, my job title is game user research, and it sounds very, very cool. And the campus is right here, and it's the biggest studio in the world, and I think that is an excellent opportunity to have it right here in the background, actually in the backyard of SFU, and in fact I can see Burnaby Mountain from one of the decks at the campus. And they also try to keep a very active life. So if you ever are curious about the studio or want to see it better, I will be more than happy to give you a tour around it. Just contact me and we can make that happen. And EA Sport has a lot of titles, and they sell millions of units and billions of dollars of revenue. So it's not something to take lightly. It's a huge, huge business, and as you see, will be linked to major professional leagues such as NHL, FIFA, Madden I was naming before. You also have Tiger Goods. Fight Night is the boxing game, so it's a whole array of different sports titles. The key part is to keep this emotional engagement with the game. You don't want to be just a flat experience, but you want to have a nice flow that you can feel connected to the game, that the actions that you're taking are helping you to do a progress that you are creating, and keep you in an emotional, let's say, roller coaster to keep it interesting, but always trying to go up and increasing that experience as you go down the road. So you have an array of different methods to do it. And if we're going to cover them, I would put in like two big buckets just to start differentiating those. So on the one hand, you will have qualitative methods, and those that you'll be more familiar with, subjective information that you are getting from the participants. Someone who should be an expert on that have to make the right interpretations just to make sure that this person is not introducing any bias or just hearing what this person wants to hear. And you can do the different surveys, think aloud methods, so the person is constantly talking as they are playing. Focus group, if you want a general sense of what's going on in the market. Interviews, one-on-one. And this will tell you a lot about why people are doing things or what's going on in their minds. But on the other bucket, we have more quantitative methods. Those are going to be measurable. Some of them can be continuous. I was putting as example psychophysiological data, and I'm going to explain further as we go down the road of the talk. And you can collect all this behavioral data, and it will give you a lot of sense about what the person is doing, what's going on in the game. So I like to think about the qualitative and quantitative of the what and the why. And each of them will give you a different snapshot of the user experience. And the more that you can combine it and do a mixed method approach, the more rich that overview of the player is going to be. So, in a specific project on this mixed method approach was using eye tracking data, psychophysiology, and game telemetry. The idea was to do a triangulation of this to have a better understanding of players' behavior and emotions with the game. So I'm going to show you an example of both NHL and NBA. Those are part of the facilities at EA Canada. So there is a play testing room with different booths. So like 18 people can get there at once and play the different games. More open space for Wii games, Kinect, and all that. Whoop. Yeah. So I'm going to present you the three big areas: the eye tracking, the telemetry, and the psychophysiological one. I'm going to start with the eye tracking. So I don't know how many of you are familiar with eye tracking, but that's pretty much self-explanatory in the sense that it tracks the user gaze. And you can pinpoint on a screen, so think about your screen as X and Y, and you can locate precisely where the person is looking at a certain point of time. So here we have a screenshot for NBA, and you can see dots and connecting lines. So those dots are going to represent fixations, are tiny little pause that you do when you're looking around. So just to have a sense of how many people have worked with eye tracking here. Okay. So even though you look around and everything looks quite smooth, actually your eyes are looking all over the place and are like going like crazy around that. And when you do this millisecond pause, that's called a fixation, and the saccade is going to be that connecting line is telling you from which fixation and what's the following fixation, so you can have a sense of how they go through time. So I like this screenshot in the sense that the player is controlling this avatar, the one with the circle underneath. And you can see that he's trying to do an anticipation, he's trying to make a strategy about what this person should be doing. So it's assessing the court situation in the sense of looking at their teammates, which one is open, which one is a better location to make a basket. So it's giving you a cue of the anticipation that the player has for the game. So with that information, you have this, you can measure in the fixation, where they are, how long they last, how they are connected to each other. And as you see longer and longer period of time of this fixation and saccades, you're going to have a gaze pattern if it repeats over time. That can give information on where the player is looking often on a screen. One thing that you want to do is to identify what is interesting for you to keep track of. One of the challenges is that things are moving all the time in video games. Everything is moving around, so it's quite hard to keep track of that. So one of the things to do is to identify what's called areas of interest. This, you see different squares and rectangles and odd shapes with different color coding. I'm just identifying different areas of interest that I would like to keep track of. So I have the player that is being controlled, a referee, advertisement, the crowd on the upper side, the coach, the score and the time, and some crowd on the bottom part. So those are the things that are interesting to me. From a game design point of view, I can see that these are different game elements that have a role during the gameplay. So I want to know actually how much time the person is looking at the character they're actually controlling, or how often do they check the time that is left, the scoring, if they're going behind or they are ahead. That might change what kind of strategy you want to do. Maybe you want to do something more aggressive if you're behind and there's little time left. So that's why you want to have all these elements, acknowledge them, and see how the player is paying their attention to them or not. Once you have moved those areas of interest as the game goes and progress, you can come up with some quantitative information about how many times the player goes and look at that specific area of interest. So from one of the players, I took a period of time and count how many times the person went and looked at that area of interest. And dividing this pie chart. So you look at this chunk and say, well, that's a pretty big proportion of areas that were observed, and it was actually the audience at the upper part of the screen, which actually doesn't have any role as a game element that you are manipulating. It's more like about atmosphere and maybe the crowd cheering at a certain point. But it's kind of like outstanding that, wow, like almost 20% of observations were to that area of interest. And a good chunk of 13% went actually to the banner behind it with the advertisement, which is great because then the marketing people says, now we can quantify how effective our advertisement in game is, and we can charge companies for a more precise amount. On the game design part, you say, okay, 12, 13% on the ball carrier. Okay, now it's making sense. It's actually the avatar that I'm controlling around. So it's starting to give you a sense of where, kind of a map of attention, of visual attention with these game elements. And then you can go back to design it and say, were you actually expecting to have the player looking at teammates this amount of time or this many times? So where they were leading the player to use. Because imagine that you're giving a game to a player and you're saying play with these elements, and as a designer you should be trying to control or lead which one you should use or manipulate more. So I cross this eye tracking data and try to find these certain common patterns. And after revising the participants and looking at the videos and looking at the game's pattern, they were kind of like two playing styles according to how they were looking around on the screen. And I put certain themes about how these patterns were composed. So one was more about attention. I wanted to see these different game elements that I mentioned, paying attention to the crowd or paying attention to the ball carrier. And when people were kind of distributing more like 50-50 on core game elements, ball carrier, versus non-core game elements, like the crowd. Whereas the other playing style was more focused on those key game elements. Another theme, very important, was checking the time, keeping track of how minutes you have left in your quarter before time's out and you win or you lose. So certain players were checking the time way more often than other players. Facts, there are certain pop-ups of information about who is the player, which foul was it, and some people were ignoring them more than others. And then I crossed it about how well they did, about the performance in the game, about using more fine-tuned features that were more specific, about the understanding of basketball and understanding of this specific NBA game. And I leave the in-game advertisement because it was also quite interesting. But it's amazing that you can actually find playing styles, but just analyzing their gaze patterns. You can recognize how they are going to perform just based on their visual attention. The more interesting part also is that once I classify every participant as fitting into playstyle 1 or playstyle 2, I went back to their demographic information that they filled out before the game session, and it was showing very interesting trends, such as this playstyle 1, the one that was a little bit more, let's say, distracted or paying attention to non-core game elements. They identify themselves as intermediate about their knowledge of the real rules of basketball. Where are the more, let's say, sharp or focused players? They consider themselves a little bit more experts. So you can see this as maybe finding differences between more experts and novice players based on their gaze pattern, even though both of them consider themselves as very familiar with the game title. And even though they appreciate sports games at the same level. Also, I cross it with some information about how they prefer to play, to see if there is also certain trends there, how often they play, and how many games they buy per year. So again, this one seems to be more focused and want to. So maybe if you want to say, well, maybe my real players are these expert people who really knows basketball and are going to be really sharp, but they actually buy less games per year. So you also should pay attention to those who buys more games per year. So and the crazy part is just by their gaze patterns and what they are looking at. One of the very interesting findings is that looking at the coach appears quite often and frequently throughout the game, even though the coach doesn't play any role throughout the game. It's just that figure wearing a gray suit standing next to the line. It's in fact we even like blend with the crowd, if you want to say. But look at all those crazy fixations right there. The person was making a basket, scoring, and then they will look at the coach. Your coach or the coach of the other team. So I was coming up with this, okay, well, maybe we should do something with the coach because they are looking at this, what I call figure of authority. Maybe they want to be rewarded at another level, not only for the score, but, you know, oh, I make a basket, look at me, coach, I did it good. So it's talking about there are more potential of certain game elements that are out there and were only picked up by the eye tracker, because during the interviews, nobody was saying, yeah, I would like the coach to say, like, well done. The coach on the other side, again, the player should make a basket, look at the coach, and then goes on to his avatar. And that one, again, that the advertisement, it is actually effective in game. And you can see even like following the shape of kind of a triangle right there and get into the reading pattern. Same happening in NHL. You can find those things. And in NHL, there was also, remember those pop-ups I told you, or those, it's more about the user interface. So you have the time here, your line change, you say how the stamina of your line, if they are fresh, if they are getting tired. So you have these more static piece of information. And I counted that if they were observed, if the person went and looked at that piece of screen, or it was ignored. As you see, orange is that they look at that, blue is that it was ignored. And it was actually overwhelming how many pieces of information appear on the screen and they are actually ignored. Actually, 75% of them were ignored. So sometimes people think that because it is out there, it appears on the screen, but people actually don't necessarily look at that. Maybe they have an audio cue and they don't need to look at it, or sometimes just missed because they are focused on something else. This one is for NHL. So you have a column with all the pieces of information on your UI. And I counted how many times they look at that. So it appears on a screen. They look at it, get out of the area of interest, and they look at it again. That would be 2 counts. And then the third column is how much that lasted. Actually, I have here a graph. So we have the 2 counts, and then the total time is all the time that is within the area of interest. And the color that they are means that they are similar pieces of information, so they look alike. And it's interesting that they even are looked at kind of in the similar number of times and for similar amount of times. So having an icing warning of a side warning is something that maybe people want to just like check up once, twice, top, really quick and go back to the game. So that even something is not observed that much doesn't necessarily that it's bad. Maybe that's, you want it to be fresh and efficient, maybe that's good. So again, you have another type of map about how much attention, how much information you are effectively giving to the people. So now I'm going to jump at the piece of psychophysiology. And now is the question of how many people have dealt with psychophysiology? Okay. So what you do with psychophysiology is actually measuring physiological signals of your body and making a translation of those signals into a psychological state. So if you collect certain pieces of information from your physiology, you can translate those into emotions and arousal. If you think about emotions as this graph, you can say that you have a positive side for emotions and a negative side for emotions. And depending how aroused you are, you'll be maybe, if you're happy and how aroused, excited, or low arousal and negative emotion of something boring. So you could take those 4 emotions as basic, or try to be pinpoint and add your emotional map around this. So, and through time, you could color code it and you can say where they are through time and have a like emotional profile of a game session. And this is the part I was saying that with quantitative method, you have something that is continuous, because for every single second that you're playing the game, you can pinpoint what's the emotional profile of the person, rather than asking at the end of the game session, so did you have fun? And ask to compress maybe a half-hour game into a single emotion, where sometimes you have moments of frustrations, if you're killed, if you lose, and then you have to restart again, and moments of joy if you are achieving and doing what you want. So this one is way more sensitive. And the kind of physiological information that you can gather to translate into that emotional profile is a GSR, stands for galvanic skin response. And you actually see in the photo, there are 2 sensors that you put on 2 different fingers of the same hand, and that's going to measure the electricity going on around your skin. It's safe. It's happening even if you don't have those sensors. And that's going to tell you how aroused, how anxious you are. So that will be filling the information for the y-axis. And then you can measure also heart rate. And this one is going to give information for both. It can be how aroused you are, or sometimes can also help you to define what kind of emotional, positive or negative side you are. You not only have heart rate, but also the variability of heart rate. If you see a bird suddenly in front of you and you have to run, your heart is going to start pumping blood, and it's going to be like a clock. Pump, 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 pump. So that's going to be really more to fear and arouse, and off you go, so the bird doesn't get you. And then I also use EMG, that is electromyography, and that one is going to measure muscle activity. So there are two facial muscles that are very related to emotions. You have the zygomatic, which is your smiling muscle. So if you see something that is good or positive, you'll tend to smile. Even tiny little bit. If someone used to watch the TV show Lie to Me, it was like kind of Eggman, but it was a kind of detective, and he could read people's mind, or people's faces, without reading his mind. And he will recognize, different emotions by these facial expressions. So instead of having this super person, you just put sensors on them, and the sensor will measure this muscle activity. Even those that you wouldn't perceive with facial recognition software, the sensors are way more sensitive, that even small, tiny things that will be recorded. And then we have a corrugator, that is your frowning muscle, and that's the opposite, something you don't like, or is confusing, or a lot of cognitive activity, you tend to do this, like reading a text and you are very concentrated, or it doesn't make sense to do that. So it could be negative emotions or really high cognitive load. And if you mix those, you can have the arousal and the emotional profile. So going back to examples, this is, imagine you are looking at the basketball court from the top, and you can make a basket with different kind of shots. And ideally those have a very clear movements, and they have a different, you would expect responses, such as getting really close to the basket and dunking the ball is rather like guttural and kind of feel like in your face kind of scoring type. Versus a set shot is more like 3 points, you're farther, you're very skillful, but it's more like smooth. And designers were expecting that dunking should be, way more happy emotion than the three-pointer, and this information is showing that actually dunking was producing less positive smiling response than a three-pointer. So you can go back to design and say, like, if you actually wanted the person to feel this way, it's not working yet. So maybe going back and saying maybe the animation should be different, maybe you should try a different camera angle, different pictures, different audio, different something. But right now, it's not giving the emotional response that the designer was hoping to get. And this one is just looking at the galvanic skin response, so how aroused the person is. And they were playing 2/4 of 5 minutes. So you can see that this participant started, okay, I'm going to play the game, I'm aroused, and then going downhill. So this is telling me that the game is actually not that engaging, that the person was actually chilling out with the game. And basketball is quick, fast, and it's sports, it's in the game, and now it wasn't in the game. So it's pretty much that the quarter is ending, second quarter starts, so trying to, again, pump it a little bit more of emotion, but actually gets down until pretty much the game ends. And the sad part of these participants is that the arousal never went beyond where they started. So I would say this game for this participant, not effective, not that much engagement, not that much arousal. But in this game, which is for NHL, and looking at the exact same thing, I would say that NHL is a more successful game than NBA. And why? Well, because I have a gorgeous 45 angle degree arousal line right there. So I superpose different people's arousal, and the darker that you see, so where there is an average, and NHL is consistently keeping people up into their arousal throughout the game. So you can start like looking at what they are doing effectively and how that can be translated to the other sports title. And again, give you a section of the emotional profile for a game. And this one I was combining for those two. So I'm combining the physiological data, and I can say, so the color coding is first period, second period, third period, overtime, and the end. And you can see that it's kind of scaling, so it's that trend that is going up, but now with emotional valence. And you can say, well, NHL people were a little bit more tense. They weren't that much happy, at least not this participant. But that's not necessarily something bad. Actually, if you play the hockey game, you're not supposed to be like laughing all the time. It's a more concentrated game. You're trying to beat your opponent. You're doing a strategy. It's not, Mario Party Wii game. So every different genre will have a different emotional profile. And maybe remember I told you corrugated is also about cognitive load. Maybe they were like really concentrated in the game and what they were doing. And they have their moments of happiness, maybe scoring, a big hit, something that was helping to do that. This one was actually what I would say like more of the most beautiful emotional profile that I've seen for NHL, where it's a really well-balanced positive and negative emotions, again, going up with the arousal, but always having a really good balance. So kind of this roller coaster of emotion, but always escalating a little bit more through time. And I'm going to mix it with the last part of this mixed method, that is telemetry. So telemetry, think about is the list of events that happen in a game. So it's the game engine, and there are hooks in the game engine that when an event happens, it gets flagged and is sent to that list with a timestamp on when that happened, which event was. And you pretty much like recreated the script of what happened in that game session. So, and with that you can see where the players' behavior in game. Are they doing passes a lot? What are they doing in game? You can do fancy statistical analysis, what's even used more. You can try to do visualizations or machine learning algorithm to predict what a person would do based on what the person have done. Synchronizing with the video, going back and forth, bookmarks on that. This one is just an example of telemetry for NBA, like shoot, dunk, miss, shot, passes, all the type of information. And I'm going to show you a visualization for telemetry. And this one is showing you when my participant was making a basket. So think again, this is the top-down view. And you'll see that those were the exact coordinates from where the person was shooting and making the basket. And you'll see that they are not scattered around that evenly. Whoops, sorry. And that actually, 91.4% are from 2/3 of the court. So you start kind of wondering, like, what's going on up here? Why I don't see those many dots? What's going on with that? And you can see that 58% of the scoring happens within the key. And you see around if different participants did the same, so you don't have outliers, and you're happy with that. And then you compare it to the locations that happen from the AI point of view. So there was a player playing against the AI, and you'll see that it's now different. And now they are not shooting from the bottom part, but actually most of the scoring location for the AI happen on the top part. And actually, instead of 58, now it's 75% is happening within the key. So first of all, you want to grab your AI programmers and saying, dude, I have like 2 hot spots right there. So those are like flaws in the games. It breaks my believability. They won't be real players as systematic of scoring over for the exact same location. Like, it's incredible. If you want something more natural, it shouldn't be 75. Should be something more closer to 60, as the real players do. And then why, participant and AI are scoring from opposite side. Like, you see, like, players, real players down here, AI up there, and you just look at that and you see that it's something off and something odd. It's something that needs more tweaking. Same thing with looking at the pass, where people are doing pass. They're going with the ball, doing a pass, going with the ball and doing a pass. And again, they have the whole court to play around, and they don't use it all. In fact, you have, again, that more like triangular shape. You have the highway of passes, and that shouldn't be, because it doesn't look as natural. And just superimposition with a real screenshot from the game. So just the top-down view, just for telemetry, and how it looks like. So you see that they come running, stop right here, and do the pass. So that might be telling you maybe the camera angle is forcing people to actually use that part of the court, because if they have the guy up here, not only looks smaller, they have problems with occlusion. If you are throwing the ball, physically, it's like going away from you. Whereas if you're playing from up there and you throw the ball, it's like you're throwing the ball towards you, and again, like a cognitive dissonance between how it feels and what's repeated in the game. So again, you go back to game designers and say, the whole court is not being used. Let's start doing some changes or some tweaks so it will be used more realistically, or a better simulation of the real game. And those were the 3 things that were the core components of this mixed method. And synchronization was a whole issue, pulling data together and having to push it together. So we have an observation of their game recording, and they will have the superimposition of their eye tracking data, camera of the player. So because you also want to record if they happen to say something that will create noise in the EMG on their face, and actually keeping the track of their physiological signals. Great. So what you do with all this information, it was these emotional and cognitive processes translate into game user experience. So it was possible to identify emotional profiles for game events, such as the shooting and what positive emotion they were creating. And throughout the game, remember this was more a quantitative analysis, so again, continuous, and you can assess where those ping pongs are. What is going on with the core game elements of the game? Are they being used? Are they being ignored? And indicate for how many? And this is information that I'm not the game designer, so I'm not going to be saying, well, you should change it like this, but I give in data and information so they can take informed decisions to make a better game. So as a takeaway, I presented like these are one of the newer techniques being used in game user research. So we combine 3 different methods, hopefully to get a better understanding and more comprehensive view of the user experience. It's different from qualitative. It's more focused on what's going on. We don't necessarily know why they're looking at the coach. I did the hypothesis that might be because of this positive reinforcement. And user experience in game is very, very complex. And this would be one way of tackle this issue with tools that at least the people in this room has or want to use or know how to use them. And it's very solid, it's very powerful, and it's needed in the game industry. So understanding what their emotions are, what their behaviors are, and what their cognitive processes are keystones of what are games. Games are for having a good time, games are for having fun, having a good experience. So we can understand that, we are actually understanding the game. And yep, that's it. Thanks. I think I'm open to Q&A, right?
Yes. So thank you. Yes, we have time for questions. We'll just ask that if you're going to ask a question, that we just get a mic to you. Are there any questions for Veronica?
I was wondering, do you actually use information from observations of real games as one, and specifically an example of that? I didn't quite understand that when you were discussing the baseball game, it had the not baseball, sorry, basketball. Obviously, I have the wrong accent for these things. You were saying that a lot of the players were scoring from the bottom left, and a lot of the AI was scoring from the top right. And you said that was a kind of conflict.
Yep.
But I didn't quite understand why that was a conflict, because I would have thought that in the case of the human players, they were coming from the right hand of the net, from their point, from the left hand of the net. So the AI was coming from the same left hand side of the net. And I would have thought that it's quite likely that something like that might turn up in a real game.
Actually, in a real game, they are more scattered. And actually, because most basketball players are right-handed, they are more likely to use the top part of the court. So your first question was if we cross it with real basketball statistics. And we weren't very thorough about it, but we revised that and look at it and look at what mainly professional players do, and they are not that heavily concentrated, 91% from that part. And actually, because they are right-handed, they tend to go to the right and score from the right. So it's actually
Isn't that what you were showing though? And maybe I don't understand the game.
So it's what's going on right now in the game. Players are using more heavily this part, but in a real this is just for the visualization part. Remember that what the player actually is looking more like this, right? So in what you're playing the game, you are pretty much looking it sideways. So you're moving with the camera like from side to side. And our hypothesis of why they are using more the bottom part is just pushed by camera point of view to have your player closer to you, so you can have maybe more fine-tuned control to avoid having your player behind other players, and then you will lose it, or it will be more difficult to actually perform other actions, which is not what happens that much in real sports games. So if part of what EA wants to do is to, actually sports games are more like simulations of the real sport. So the closer it is to the simulation to a real sport, the better it would be. And even though it's pretty good, it still has some flaws.
We have a question over here.
Hi, thanks for coming. That was really interesting. One thing I saw with the eye tracking that was a little disturbing was the amount of attention that was spent on the ad banners. Yeah. And it seems to me if they're spending all that money on the game and then the company is turning around and selling their attention to the advertisers, it seems a little sneaky, but also there was a place where they weren't paying attention to some of the stuff that was going on in the game that might have been relevant to the game. Yeah. And I'm just wondering, I know you're just a researcher, you're not making the business decisions, but have you ever been able to do a study where you had it with the ads and without the ads, and maybe seeing if that enhanced the user experience, and might be able to look at it from that point of view?
Yeah, that's an excellent question. And the pie chart that I showed is particular from one player. So it was a kind of a tendency, but I wouldn't say this is the experience. So the in-game finding, it just happened. We weren't looking for that. We were just concentrated in gameplay, but we noticed it, so we put it in our findings list. They would be like, we would love to do a lot of A/B testing about, let's change this, let's get rid of the advertisement and maybe have a more qualitative question at the end, or maybe even with the psychophysiological to see if the trend is different or if it remains the same. We haven't had time to actually do a completely different build of the game and test that. But there are so many things to test that actually have to choose one. And you know, in get advertisement, it's also good. So as long as it doesn't overshadow the game, it's fine. If we see that people are, you know, having a bad time, or if I notice there was a consistent drop when they were looking at that, well, that would be something like, you know, to call and say, let's put advertisement somewhere else, or be a little bit more creative about it, because it's damaging the game, and that's something that you don't want to do, because in any case, people will be less likely to play it, to buy it, and then you won't have any in-game advertisement.
You have a question here?
Everything that I saw you present today used as a grain size the entire game. Do you partition the segments in, for example, basketball when a pass is intercepted or a shot is missed, and look at that conditionally in relation to some of the dependent variables that you use? And if so, what statistical work do you do on that data?
Could you say the question again? I missed.
So in basketball,
yeah,
the common event is intercepted pass.
Yeah.
So would you slice the data stream to start at a point where a pass is intercepted and then track it, for instance, to some other major event, and contrast that with occasion when, for example, a pass is completed, or when a dunk, rare, I imagine, in the game, but when a dunk is missed, and it sometimes happens, particularly in collegiate sports.
We didn't look at that. That was something that was in our wish list, to-do list to do. but we didn't look specifically at intersections. It's just because actually when I started this project, as you know, like the scope was huge. Let's look at the whole game and all the variables. So I would recommend to keep your scope narrow and focused. It's good for your health. And we didn't notice any like red flag or something too odd or too off with from the telemetry, and trying to link it to either night tracking or psychophysiological. But it's something to look. We didn't look at that yet.
Another question up front.
Hello, I'm just wondering if this is something that a developer has or has expressed interest, as far as you know, in implementing something like this, because it seems like it would be very, very costly, right? Because you have to first create the game, and then after the game is created, you have to play test it and find this data, such as the kind of data that you found, and then go back and play test it, and then maybe that didn't work, and then play test it again, and play test it again, et cetera, et cetera. And especially in a game that isn't one where you're just looking at a pretty static screen, you know, a first-person shooter where the environment is completely open. That seems like it would be a lot more difficult to do, especially when the developers are just trying to crank it out as quickly as possible to make, you know, to meet a deadline. So I'm wondering if this is something that would actually could be used in a useful scope to improve the game.
Well, the thing is that EA sports titles are yearly basis. So you have FIFA from 86, 87, it's every single year. So the advantage and disadvantage of working on a sports title is exactly that. Actually, because it's in a year title, the development process is even shorter. So it's actually 9 months top. And that's super, super tight. So on the one hand, it goes to user experience sessions, and you come up and find this, and then you go back to them. They are like, I have 3 months to ship this game. I don't have the time to all these things. I have to pick maybe a major aspect, and the rest, oh no, for the next year or for the next year. So on the downside is maybe a lot of things that pop up won't be used. On the bright side is that it might support better a new feature for next year, and that will have a little bit more of time of having a new, different iteration and test it again.
I have a related question to the last two. I mean, obviously, Phil Whinney was bringing up all the possible things you can do. There's so many of them.
Oh, yeah.
And then you were talking about some specifics in timeline.
Yeah.
And I'll at least let you know that we're filming, and it will go on the web. Since I'm going to ask you about your employer, you could answer with all that in mind. But as a cognitive science person out there in a new area that's so exciting and so amazing, all this data, obviously you're educating your employer and the producers at the different levels of, because I'm sure some people want answers to things that you can't really do yet. Others want everything. Others don't want, or just trust their own instincts and don't want to listen to your data. And I know you also are on the road a lot, representing EA at conferences. So you're actually, in a way, an ombudsman for this kind of technique, kind of pushing this technique to the industry and what makes sense. Hence, like one of your last pieces that said, we don't judge, we just give it to designers. And I thought that must be there specifically when you go to GDC or something. So I'm curious, just how much do you think your role is to explain, support, even slow down what people think this whole technique is for?
That's a tough one. It's a really delicate balance, because the designers come with this game, and especially these yearly titles, that they are very, very robust already. And you can make suggestions. You can highlight with yellow, put read underneath and try to pinpoint what are the most important ones. And then it's again like a whole playing around how much time is left, how much time they will have to implement that feature, or may actually that correction, because maybe you will break something even bigger. So it's a craft, really. Making games is a craft.
So for some of the young people in the audience, so this literally is something you did as a research, and then you're kind of almost a team of two, and people know you at this new group. Do you find, even in this short period of time, that it's successful, and you really think this will, either your department will grow, or we'll be seeing a lot more work like this in not only the game industry, but other, like the movie industry and other places?
I think that we are definitely in the right direction. Even for this like new department, like the Advanced Usability Lab at EA, we have a really good track of what are we capable to do, and because we are bringing this new toolbox of methods, it's not something that you have to tell people, tell me what you're feeling, what you're thinking, is the game good, is it? It's now you can be more subtle. Now you can like try to tap in the subconscious, so you can get in completely new set of information that years ago wasn't available for video games. So I'm completely sure that this is like on the right track. We're getting a lot of questions from different development teams to how can I know this? Oh, now with the eye tracker, I can know if they're looking at my menu in this way, or I can looking at my new design in a different manner. So therefore, it's also excitement from these game designers that now they have a lot of questions in their head, and there was like no way to answer that. So we are excited because now we can learn that, and they are excited because they can get this new information. It's creating totally a new trend of what you are capable to do in game user research in both like industry and academia. And industry is taking more seriously, being more scientific, more rigorous, that you can actually, what you're talking about, and you can apply it. And they are reassured that that's going to end up in a better decision.
You had a few beneficiaries. The prime beneficiary of your work was for game designers to make sure they're not either making an accurate rendition of a boring game or an inaccurate rendition of an exciting game, but they make it a better experience. Target audience 2 are the advertisers for product placement, and to know how much to quantify how you charge for that. And incidentally, target audience 3 would be like this audience here today. The cognitive science insights come out of your work, and it benefits the science. You saw how Eli Wallace was recruited by the SGU, or you don't watch television? Okay, sorry. The movie The Last Starfighter. Okay.
I do watch.
Yeah, you played. And I, for my part, the last time I played a video game was 1987, so we don't have much to talk about. Where online networked video games were being tracked by people who were using it for individual profiling of gamers based on their performance. And in The Last Starfighter, they found out this super shooter, starfighter game, and they recruited him to fight actual aliens. In Eli Wallace, he solved an extremely difficult problem in alien code, and so they brought him to the spaceship to do that for a living. Not that far out, but you can see how there are audiences for profiling of individual characteristics of individuals, for recruitment, for good things, bad things, and different things. And the whole, well, to make it a simpler question, what's the level of privacy for your statistics gathering for networked? I guess in your experience, you only use people who are agreeing to participate in the experiment, and they know that you'll be using their data, and they know the extent to which you'll be sharing the results.
Yep.
But
in fact, they also sign NDA agreements. So if we are showing something that is a new IP or a game that hasn't been released,
Oh, sure.
They have to agree that you're not going to talk about it, that you're not going to have your phone and take photos. So I think it goes both ways. It's not only like the company keeping safe their information, but also that the information of the company will be safe from the participants.
That's good. But in network gameplay,
Yeah.
are there privacy agreements that people? What is the privacy situation? Like you could share statistics for networked Grand Theft Auto with the RCMP, the people who are the most enthusiastic, greatest players. They'd be interested in that. Where are the lines drawn there?
So I can tell you what I know, but maybe that would be a bigger question for legal department at EA. So if I want to see regarding telemetry, so the ones that I do on-site, that goes to a specific server, and I know that that person played that match. And as any other experiment that you will do anywhere, you keep the person safe about their identity or any other piece of information that will be personal and you have given. So that's for sure. And then if I want to see telemetry from the real world, I just see numbers. I never see any name or anything that I could associate to anyone. So to me, it's just numbers.
But so the closest you can get is product placement within targeted games based on the person's reactions and profiling. A certain advertiser would most like to be in touch with that player, and so you place the product placement ads in their experience of the game on a network.
I mean, I think you're pointing out something that is really significant in the future. Just because she's a cognitive science researcher, she's doing the standard ethics and small control group that a lot of us do. But I think in the future, especially if this is part of the Connect control box, for instance, these are kind of standard kind of Google, Apple privacy issues, you know, and it gets down to almost body privacy, which is not only do they know what I'm doing, they know where I'm looking, right, and they know what I'm thinking. But I think this work, as a lot of cognitive science work, is gonna show that as we get more data that we can take off a human, that we really have to think about where the limit is. And your work is showing, at least in kind of more in a lab study setting, what's possible. But this isn't out in that kind of real world. Actually, Mark Blair is doing some work that is looking at some of the data you can get now. So it's it is a real issue. It probably isn't a real issue with the, you know, I think the thing you have to watch is when there's a mouse, and the mouse has the galvanic response, I think, which you can almost buy, right on it now. And as you get into these more, as you get more ubiquitous, and again, the Connect, you have to be careful. It is tracking where you're looking. It does track that you turned ahead because somebody in the room has called you. So, you know, it's not all exact game data. I think some of these points are really significant, something we should, you know, everyone in this field should keep an eye on, and as experts decide, you know, where we think policy should happen. Although you're more doing it in kind of an early stage in a very controlled kind of ethics kind of environment.
Yeah.
Keep it up.
Thank you.